Welcome to our Learning from Data seminar. And today's talk is given by Dr. Parsa Bakhtary. We are very proud to have him since he's a KFUPMer too. He's been here with us for 3 years from 2009 to 2012. And he was a very good colleague. And now we are very proud to have him represent us the US. And from now on, I'll let him speak. Go ahead, Parsa.
Thank you, Dr. Belhaiza. It's a privilege and an honor to have this opportunity to speak to young minds who are interested in data science and analytics. Thank you for this opportunity to address your students, and I hope I can entertain them as well as educate a little bit and give you folks some insight into what it's like to be a data scientist in Silicon Valley. So, assuming everyone can see the slide deck, I'll go ahead and begin.
We can see that. Go ahead.
Great. So my name is Parsa. Some folks, I guess in Saudi, prefer Dr. Bakhtary, but whatever you're comfortable with. I also encourage you, if you have any questions, to please write them down and save them towards the end, where we can have a Q&A session and discuss any questions that you may have about any of this content that I covered, or even content that I haven't covered. I cannot guarantee that I know the answer to your question, but I'll do my best to try. So just a little bit about me and my background. I studied at Purdue University for 7 years in algebraic geometry, from my bachelor's to PhD. And as Dr. Belhaiza mentioned, I was at KFUPM for my postdoc, 2009 to 2012. After that, I entered industry. So it's been about 10 years now that I've been in industry. I began as a business intelligence and game analyst in a small startup in Chicago, Illinois, in the US, which was later acquired by Zynga, the gaming company based in San Francisco. After working there for some time, I moved to Las Vegas, where I did slot mathematics and game mathematics for the gaming industry there. That was a very brief excursion, 5 months, and then began in earnest my career in data science at the highest echelon. And it's been a wild ride. I spent 4.5 years as a data scientist at Facebook before they became Meta. And then after that, I became very fascinated with video, since I worked on video at Facebook, and went into video analytics and video data science, and became a product analyst at YouTube for 4 years. I should mention, a product analyst and data scientists are often somewhat interchangeable in Silicon Valley. And then recently in July, I left YouTube and joined Roblox, a gaming platform also based in the Bay Area, as a senior data scientist. So I will try to kind of give a high-level overview about how the teams are structured and some of the biggest problems we solve. And I won't delve too deep into the models or the mathematics or even the implementations and engineering. What I want folks to pull away from this talk is sort of to understand what the biggest problems that we attempt to solve in Silicon Valley are. Before I do that, I wanted to give everyone an idea of sort of how the teams are structured, since in school you have your classmates and you have your professors and perhaps teachers' assistants, professor assistants. In the product team hierarchy, you are one component of many. Usually you have a product manager who is the vision for how a product is supposed to progress. You have the engineering team, which are the engineers, the software engineers that implement the actual code. You have designers, which will design the layout of apps or websites or even just functionality. You have me or someone analogous to my role, which is the product analyst or data scientist. You have a UX researcher whose job is to go out and interview people face to face or through surveys to understand how people think they use the product. And then you have content strategists and other teams. Content strategists are the people who actually design the language or the wording of a website or an app that you see. So they're the ones that decide whether the term should be called follower or, perhaps, fan or these types of things. They choose the language and the translations to different languages. So that being said, what is the role of the data scientist in this? We are the voice of evidence. Everyone in the team has a kind of gut instinct, as we Americans typically say. My gut tells me we should do this, or I have a feeling we should do that. The voice of the data scientist or the product analyst is to share evidence of how people are actually using the products that exist. So that's something to keep in mind. Now, what are some of the biggest problems that a product analyst or a data scientist attempts to solve in Silicon Valley? Well, they are numerous, and I cannot begin to cover all of them. So I tried to pick a sampling of some of the more interesting ones from apps or websites that you may be familiar with. So perhaps you're familiar with Netflix or Hulu or HBO Max, Paramount Plus, Peacock, these video streaming apps. YouTube is also an example. So when you usually open up those apps, you see a list of recommended shows or content for you to watch. So one of the things I wanted to address is, how do people build a recommendation model? How does YouTube or Netflix know what to recommend to you in that you might have a high likelihood of watching? A second big question is comments. And this is perhaps, when I did this, Facebook was large. Nowadays, perhaps you might think of this in the context of Instagram or Twitter, which is a very, comment heavy platforms as well. And the idea is to automate the removal of poor quality comments or profane comments or elements of bullying, incivility, these types of things, and surfacing what we think of as intelligent comments or meaningful additive comments to the conversation. And that's also a very challenging problem that Facebook tackled early on, and Twitter and Instagram are still tackling, and any platform. YouTube had to tackle it as well because people comment on videos. So anywhere where there's a rich ecosystem of commenting, you're going to have to try to moderate that in an automated fashion, since you don't have enough people to actually go through each and every comment when there are a billion people on your platform. And finally, I wanted to touch upon one of my own personal projects at YouTube, which is detecting data throttling. And that we'll get into a little bit more later, where we discuss a real data science issue and not so much just an analytics issue. So if you're curious about what the difference is, analytics is coming up with the right metrics for success of a product, and trying to measure the right things, making sure you're measuring the right things and reporting them correctly. The data science aspect is more challenging to some. Perhaps it involves machine learning, excuse me. It involves machine learning, more intense mathematical modeling and prediction. So 1 in 3 are very, all these problems are data science, but you should also keep in mind analytics is measuring the key performance indicators and the health of a product. So they're not quite as interchangeable as some people suggest. And then for the mathematicians and those in the audience that are advanced mathematics enthusiasts, we have some other topics I wanted to briefly touch on. And then for those that perhaps are less interested in the advanced mathematics and more interested in the high level analytics and questions around products such as Facebook, Instagram, Netflix, YouTube. I wanted to touch upon some simple questions that CEOs often ask, but are surprisingly tricky to answer. So those are the kinds of things I would like folks to be thinking about as you consider a career in analytics or data science. So, number one, Netflix is a great example of a content recommendation system. And that's sort of, the phrase that we'll use for websites like Hulu, Netflix, and YouTube for the moment. They're media, video content recommendation systems. So when you load up Netflix loading screen, you might see something like this. This was taken from like, I think 2 years ago when I initially gave this talk. My content is much fresher now, I assure you. But this is the type of trays that you might see. Each one of these rows is often called a tray. And we have a trending tray, a top picks for Parsa tray, and popular on Netflix tray. So each one of these has its own sort of recommendation algorithm. Now, without discussing any methodology, take a moment and think, how would you begin to recommend content to people? People who you've never met, people who just appear as data points on your app. How do you go about recommending a show to them that you think there's going to be a high likelihood they will actually watch? So there's many different approaches to how we can build these types of models. You can do very fancy types of models, which involve deep neural nets, which model the human brain using neurons and probabilistic flags. You can use what's called gradient boosted trees, which is very popular. It's got some parameter tuning, so there needs to be some fine tuning of these models, but they're very effective. Random forests are very popular in Kaggle competitions, if you've heard of that. They are kind of like the hammer that everyone uses on every nail, and it always produces a pretty decent result. And then there's collaborative filtering, which is actually a very powerful method. I'll touch upon this a little bit more because you don't really need a ton of math to understand it. But let's say, we look at you and we look at the stuff you watch, and then we look at someone else and we look at the stuff they watch, and we notice there's some overlap. Let's say you both enjoy Game of Thrones, or you both enjoy watching Stranger Things. And then it's possible that some stuff that this person watches that you don't watch, you might like, because you match on other types of content. So typically what this involves is grabbing two people that share some interests and then surfacing other interests of one person to the other. So this is called collaborative filtering, which is a very powerful method of recommendation. There's also very cool features of the model itself, not so much the model that you're using, but the features of the model. So content-based, do you like anime? Do you like comedy? Do you like adventure or action? Do you like horror? So the nature of the content is important. Or perhaps on YouTube, you really enjoy a particular content creator. That's another sort of content-based signal. There's format. Do you like animation? Do you like slow-paced shows where the format is like potentially medium quality but slower paced? Do you like very high quality format, 4K, HQ, this type of stuff? Audio quality, these types of things are format based. User-based or behavior-based. Or user-based is typically like, what country are you in? How old are you? Are you male or female? These types of things also influence what content you're surfaced. And behavior-based is a classical one. What have you watched in the past? And that will influence what you watch in the future. What do you think the objective function is? Now, you may not have heard the term objective function, so I'll briefly tell you what it means, but it's basically the thing your model is trying to accomplish. How do you know if your video recommendation model is successful? Well, if people click on stuff and actually watch it, right? So there needs to be the goal of the recommendation is not just to get people to click on a show, but actually to watch a show or watch that content and perhaps watch multiple episodes of that content if it's a TV serial, or if it's a movie, to watch at least, I don't know, 2/3 or 3/4 of the movie. So remember that the objective function is not just clicks. So for instance, when you're serving search results on Google, clicking on a link is generally seen as a sign of success of the model. But for content, like video content, clicking is not good enough. You need to recall that the objective function is retained watching or time spent watching of the content. So that's something to keep in mind. The features in objective function are usually more important than anything else. Oftentimes, if you go look at data science blogs or you go on Twitter to discuss data science, everyone loves talking about the different models that they're using. And it's very fashionable to discuss different models, such as, oh, do we use boosted trees? Are we using a convolutional neural net? Are we using, some simple multilinear regression? But oftentimes, the model itself is much less important than the features that you're feeding it. A great model with poor features almost always does worse than an average model with good features. Features being what we discussed in the previous slide, what kinds of inputs you're putting into your model that determines whether or not you think someone's going to want to watch it. Okay, these types of details are something to keep in mind. If there's one takeaway you take from this talk, it's that the inputs into a model, the features, are the most important thing, and developing a good intuition around what features will give you better outcomes is really what the best modelers have, is that intuition, not necessarily the most sophisticated models. Now, we discussed content recommendation. Let's take a moment and discuss intelligent comments. When I was at Facebook, I worked for about 4 or 5 months on the comments team, the public comments team. And public comments are not the same thing as comments that your cousin might leave on your Facebook post or your Instagram post. Those are typically more private and more personal, and those are generally going to be pretty high signal. But imagine you are a magazine or a famous celebrity, or some entity like a fashion brand like Pepsi or Nike, and you make a post, and then every time you make a post you get 1,000 comments, right? You want to try to surface the most interesting and intelligent comments to people when they see it, because there's just limited space on your phone or on a website. You can't expand to 1,000 or 2,000 or 5,000 comments. So you really want to rank them in a meaningful way. As you can see in this slide, Humans of New York was a very continues to be a very popular Facebook page, and you can see just on that post there are roughly 7,500 comments. 7,500 comments, and what a typical person sees is maybe 4 or 5. So you need to pick the best 4 or 5. That's a very challenging exercise, because you are dealing with a machine learning algorithm which doesn't know what words mean, right? So you start again looking for signals or features that kind of are correlated with what you perceive to be intelligent. You know, some examples are more characters, longer comments, fewer emojis. You know, maybe you want to avoid links because spammers like to use links in comments. Trying to make sure it's relevant to the content of the post. If your post is about, you know, a pet bird, then you don't want the comment to be about a car, for instance, or something just totally unrelated, right? So these are types of like things that you should try to keep in mind. Other things you should keep in mind is from the analytics perspective, what do you think happens to people when we start showing more intelligent comments? One of the most fascinating things we saw was that as we began to rank better and more intelligent comments to the top, the volume of people leaving comments declined because they were busy reading the comments rather than writing them. So there's some consequences, and that was something difficult that we had to explain to our leadership at the company, that, hey, we're surfacing better comments, but unfortunately, people are also leaving fewer comments, right? Another big problem is also called the first mover problem in commenting. The first mover problem means the first people to comment on a post usually get the most likes just because they were the first. And those comments, if you're just ranking on likes, typically float to the top. So that's not great because you don't want to just reward someone for being the first person to comment on a post. So that's called the first mover problem. And these are types of things to keep in mind as you start testing out different models. Another amusing thing is spam. Spam also becomes very, very clever and adapts to the models. The better you are at filtering out spam comments, the more intelligent spam comments become. So again, we go back to the objective function. What is our goal, right? Is your goal to get people to read comments? Is your goal to get people to leave intelligent comments? That's the kind of thing you really want to iron out and make sure everyone agrees on before you go and start building models. Getting this type of agreement is absolutely critical. Typically, we use a boosted trees model, but one thing to keep in mind is how does your model know what's a good comment or not, right? You need to have examples of good comments in order to train your model so that it recognizes them. How do you figure out what's a good comment if you don't already have a model? Well, you have to hire human beings, right? And so when you hire human beings, that's expensive, but you hire people who get paid by the hour to literally read comments from some small subsample of comments and say, look, on a scale of 1 to 5, this is a 4, this is a 2. And so what they do is they rank comments based on actually reading them, and then that's your labeled data that you train your model on. Here's an example of a before and after situation for Humans of New York. Initially, we just had reverse chronological, which means we would put the most recent comments first. And look what we saw. It was just people tagging other people, right? Hey, come look at this. Because tagging someone sent them a notification and you're like, oh, this is a cool post. David would love to see this. Let me tag David, right? So that's not great for someone who isn't David, right? You want to show comments to people who weren't tagged, and so after you look at kind of relevant, most relevant refers to one of the comment ranking models that we implemented. And here we actually get a long, meaningful, relevant comment that is, connects to the post and attempts to connect to the audience. You could see, it was very well received. So this is an example of a before and after in terms of surfacing intelligent comments. Yeah, one more thing I should mention is not every company can afford to hire human beings to rate comments, and even when they do, they can only afford to hire hire them to rate them in one language. So it's a very big challenge when there's 70 to 80 different languages that are commonly used in an app that 1 billion people or 2 billion people use. So coming up with comment ranking in Mandarin or in Arabic or in Spanish or in many other languages becomes, a big challenge without human beings to tell us what's a good comment and what's not. So certain things, there's limitations on the models you can build based on the budget that your company has. The final project that I wanted to discuss with you, this is one of my personal projects. It was the first project I was given when I joined YouTube. And this is a sort of one that's very, very interesting. So typically, YouTube is the #1 cause for people running out of data. Or it's the #1 drain on mobile network operators as well. Operators like Verizon, ATT, in Saudi Arabia, you have STC, Zain, Mobily, right? So all of these mobile network operators, their biggest expense is often YouTube. And even if you remove YouTube, it's still video. Video streaming takes a lot of data. And if you're trying to watch higher quality, then it takes even more data for the same amount of video. So 5 seconds of video at 1080p takes a lot more data than 5 seconds of video at 480p, for instance. These numbers are sort of video quality. If you're familiar with pixel quality of video, they're measured in terms of numbers. You may have heard of 1080p being HQ, high quality, HD, and 4K is even higher than that. So these are the types of video quality. The quality will affect how much data you consume. And for every mobile network operator, data consumption on video is what they worry about. So in order to sort of manage the load of all the people trying to watch video, what they do is they purposely slow down some people's connections and they purposely speed up some other people's connections. And they have to do this because otherwise the people that live close to a cell phone tower will always get better quality video and more of it than people who live further away. So some carriers also often offer unlimited video streaming, for instance, or unlimited YouTube. And in order to do that, they need to target a specific resolution like 360p or 480p. So they throttle you. Throttle just means they push you within a certain band of throughput, which means the speed at which you download data. And they make sure you stay within this type of band. And so YouTube tracks this data, how much media bytes we send and how long it takes to send them. So we basically compute a velocity. This data velocity, the speed at which people receive data, is called throughput. Sometimes it's also called goodput, which is basically throughput minus metadata. So for each carrier, we can then plot a graph, this histogram of the percent of playbacks or even just throughput requests at a given speed. And what happens is when a carrier like Zain is throttling, we can see a big peak in this graph. So what happens is for every mobile network operator in the world that YouTube runs on, and that's pretty much every single mobile network operator in the world, we get a graph like this. So Mobily has a graph like this, not necessarily like this, but Mobily has a graph like this, Zain has a graph like this, AT&T has a graph like this, Verizon has a graph like this. Every single mobile network operator in the world that plays YouTube for its customers has a graph like this. Some of them don't throttle, so you don't see peaks. Some of them do throttle, so you do see peaks. In this particular graph, you see a throughput histogram for a major wireless mobile network operator. The x-axis is the transfer speed, and the y-axis represents the volume of data requests. So when you see a sharp peak right here in the middle, that's the mobile network operator targeting 360p for video. And maybe 360, maybe 480, and then a little bit further, you see that second peak. Those are probably like the more expensive data plans, which offer 720p. So they throttle this to be able to afford it and to have the bandwidth to send this type of data for everyone. YouTube asked me to tell them which network operators were throttling them. Well, there are over 1,000 different mobile network operators. Actually, if you include the smaller ones, more than 1,000 across the world. So I'm not going to go through, several thousand graphs manually labeling peaks, right? We need to do data science on this. We need to find an algorithm that detects peaks to be able to say, one, which network operators are throttling us. Two, how much of YouTube watch time is throttled watch time. And three, when someone changes their throttling behavior, so a before and after. And this really just boils down to what's called peak detection, which is one area of data science. And in our case, automated peak detection. So I read some papers. There's some really interesting methodologies here. I used a relatively simple methodology, which does a moving average smoothing and does a local regression to find peaks. There are some other more sophisticated methods, more for like real-time peaks that are being generated in real time. I was dealing with historical data, like data from yesterday, so I didn't have to worry about the graphs being generated in real time. But there are also what are called continuous wavelet methods and momentum-based methods, where you sort of imagine a ball rolling across the graph and thinking where the momentum would take it in order to find valleys. And so in essence, you can flip the graph upside down, roll the ball, and wherever that ball stops is typically like a peak. So generally, you need a combination of smoothing, baseline correction, and peak detection. And there's a little bit of guess and check and parameter tuning to sort of get this, but eventually we got a pretty good model out, and we were able to say which mobile network operators were throttling YouTube, how much throttle watch time we were generating, and which ones were not throttling us before and now throttling us. And we were able to flag these mobile network operators to make sure our YouTube employees could reach out to those partners over at these mobile network operators and work out alternate solutions which don't involve throttling, which would be sort of like a better user experience for people trying to watch YouTube on cellular connections. So we're almost out of time, so at least for the presentation, I want to touch upon some more advanced topics, which I find super interesting. One of them is in the field of medical imaging. It's particularly interesting in the context of tumor imaging and oncology. And this is what's called topological data analysis. So imagine you don't actually know what you're looking at, but instead you have kind of a point cloud, like kind of here you see a point cloud of a torus or a donut. And so oftentimes you can shoot light at something and get a type of point cloud. And so with tumors especially, and in oncology, you can sort of detect a shape of a tumor by sort of shooting particles at it and then generating a point cloud, which kind of gives you an idea of the shape of a tumor. The problem is, unless you have a lot of points, like in this example here, you don't always know what you're looking at. So oftentimes what you do is you replace the point cloud with little balls around each point, and then what you do is you generate what's called a simplicial complex in topology, and you manage to take sort of a homology. And homology is really just a fancy term for sort of measuring the number of holes and stuff. And so it turns out that if we have a good idea of what the shape of a tumor is, along with other types of aspects, we can actually predict with some accuracy whether or not what the prognosis is for those types of tumors. And so there's a fascinating art. So Carlson's paper sort of outlines the theoretical aspects of topological data analysis. And the second paper I linked there, Bakhtary, Andor, and Darcy, they highlight its application to oncology and tumors as well. By the way, let me go ahead and link this in the chat at some point. Oh, I don't have a chat here, but I'll send that to Dr. Belhaiza, who can share it with folks. But in case you're actually curious about what the content of these papers are, that's one place. Another company in Silicon Valley based in Palo Alto is Ayasti. Ayasti was using multidimensional topological data analysis to understand credit card fraud. So it turns out that certain types of purchases off of credit cards are flagged as suspicious. And typically there are older models which sort of look for features, that are very intuitive, such as large purchases in locations that are not typical to the user or the credit card owner, these types of things. But their company actually used more advanced methodologies like topological data analysis to improve upon the existing fraud models for credit card purchases, for instance. So there are multiple applications of this. And it is a kind of a fascinating applied algebraic topology kind of view at data. The other one actually is the one that's very close to my heart, because in algebraic geometry, if you recall from I guess the second slide, I studied algebraic geometry at Purdue, and it was what my area of research was when I was at KFUPM. And algebraic geometry is a very esoteric, like obscure kind of area which uses sort of algebra to study geometric objects, and it uses what Fields medalist Alexander Grothendieck sort of popularized along with Jean-Pierre Serre, which are called sheaves. And sheaves is basically this kind of advanced mathematical object, but really the way you should think about it is the following diagram. Imagine you have a bunch of change on a table, and you have snapshots of portions of the table. And you can glue these snapshots on overlaps and get a larger image of the table, and then tell us how much change there is on the table. And so this type of gluing on local images to create global images, it's basically a phenomenon that we use in algebraic geometry. Turns out you can also use this in sensor analysis. So imagine you're tracking animals in the forest, for instance. This Joslin paper from 2020 tracked bears in the forest. And so what happens is you have, let's say, like 5 or 6 cameras that cover a certain space in the forest. And what you're trying to do is you're trying to track an animal, for instance. Well, you'll take certain snapshots in periods of time. And the idea is sometimes you can glue these snapshots together to figure out the entire path that the bear took. That's one example of understanding like sensors and in the context of sheaves. There's actually a lot of other interesting applications to this that haven't been worked on yet. One of them potentially is even trying to understand geolocation of even missing airplanes, for instance. If you have sensors that are measuring their tracking, like from the plane itself or from external sources like sky towers. So tracking, geolocation tracking is one application. Video camera or closed caption surveillance of like city streets is another one. If someone commits a crime and you have a few snapshots of them at different points in time, are you able to glue that information together in order to track their movement throughout the city? So this type of sensor integration, sensors and sheaves, is also a very new area of research and a very new area of mathematical data analysis. So some things to think about, as you pursue more advanced topics and more advanced mathematics. For those of you interested, that there's a lot of really fascinating new techniques being developed even as we speak. And finally, for those of you who are more interested in sort of the high-level questions that we deal with in Silicon Valley that may not be pertinent necessarily to the actual mathematical techniques initially, but are questions that are frequently asked by CEOs. I've been asked questions like these by Mark Zuckerberg, who is, you may know as the CEO of Facebook or Meta. I've been asked questions like this as well from Susan Wojcicki, the CEO of YouTube, and I've even already presented to the CEO of Roblox as well. These types of questions are constantly appearing in these types of meetings. Retention is a classic one. What makes people come back to an app? Oftentimes when you first launch an app, retention is one of the first metrics you look at. Okay, who downloaded it? And then who came back to the app after they downloaded it? How many times did they come back in the following week? Did they come back 2 weeks later, 3 weeks later, 1 month later? What can we do to increase the volume of people coming back and doing something? Okay, so in any case, causal inference is another one. Did doing X actually cause Y? Sometimes you can measure it. And then finally, proxymetrics. If we can't measure something directly, what's the closest thing to it that we can measure? So these are some simple but tricky questions that I wanted to touch on. And I think we're getting close to the end of class, so I'll try to save some time for Q&A at this point.
Thank you very much, Parsa. Thank you. Very, very, very good presentation. Guys, it's up to you. We have time for 1 or 2 questions. Please don't be shy.
The first question always takes a few minutes.
So, Abdullah, go ahead.
Hi. I thank you first of all for being here at this very late hour. We really appreciate it, and also thank you for Dr. Salim for arranging this great seminar. I actually have many questions because you said many interesting points, and it's honestly it's a little bit confusing what to pick. But what I'm gonna do is I will say my questions. You could pick whatever you want to answer, and we can move on.
Sure.
Do you think we can do that? Okay. So first of all, as someone who would like to get into data science, it's a bit confusing because people do not agree on a specific definition. So for example, I think when I first got interested into that field, maybe 2 years ago, one definition was that data science is sort of the master of all, that he does data analytics, then he does machine learning, then he does AI on that, and then he can call himself a data scientist. And some people say there is data analytics and data science, and I honestly don't know what's the difference between them. But just for me, about the same thing.
Yeah. Sure. Are there other questions you wanted to flag as well besides that one?
Yeah, so this is most the theoretical. The two remaining questions, which as again you can choose whatever you like and answer it, is regarding comments. So comments it's a very interesting topic, and I think it varies from one application to another, because sometimes you when you are a user, you need the most recent comment. You don't want anything that is filtered, and there are some instances that this come in handy. Also, sometimes you need the algorithm to choose some comments.
Mm-hmm.
And other times you want the best liked comment, and there are applications. Some applications has different algorithm that fits it. So, for example, Reddit, the most like is the go-to strategy.
Let me stop you right there, because I already know sort of where you're going. What the trend that's moving to is letting people choose how to rank the comments themselves. So Reddit, for instance, has the highest upvoted comment as one method, the newest comment as another method of sorting, the most controversial comment, the best comment. So it actually offers you different ways of selecting the comment ranking that you want. And this is sort of the way that comments are progressing. Same with Facebook as well. You can choose to rank it by reverse chronological. You can choose to rank it by filtered. You can choose to rank it by most relevant. So with regard to comments, you know, the way that the people are progressing is to have a bunch of different models and sort of give each one a name, such as best or, you know, most controversial, or, you know, so on, and then offer that option to the user to rank comments for themselves. What I did highlight in my talk is like most liked comment is often not the best comment that people want to read, and we've seen this in experiments. Briefly touching upon the definition, frankly, data science is whatever you want it to be. You know, I've heard everything. People say, "Oh, this isn't real data science," or "Only AI is real data science." Data science is whatever you want it to be. My first job was just pure, you know, data analytics. But with the beauty of actually having access to massive amounts of data is that, you know, you do your job and then you can do whatever you want on the side with that data and introduce it to your colleagues. So my takeaway is that data science is literally whatever you want it to be. Don't let other people limit your definition of it. And the best thing is to just get in there, get access to data, and start working with it, in whichever manner that you enjoy.
Thank you, Abdullah. Do we have time, Parsa, for another question?
I'm happy to stay until the end of the hour because
Yeah.
I did go a little bit over, and so I wanted to field at least 3 or 4 questions before heading out.
So Mohammed, go ahead.
Yes. Thank you, Dr. Parsa, for taking the time. I know it's a bit troubling, but thank you, and I would thank Dr. Berheza for making us hear from someone who is deep in this field. I had a question about the serving of comments, because in my summer training, I had an instructor who has working on a paper on Twitter. And he asked us to filter the comments based on some criteria he gave us. But I noticed that he didn't care about bias, because sometimes I can see things or I can go with things and others may not think about it, or sometimes I just did not do the job right or something as he thought. But for me, I thought it was complete. And this issue, how to attack them and solve this issue and make sure that you don't have to go and review what someone did and make sure that is not bias.
Yeah, so the problem is there's different kinds of bias, right? There's like what I mentioned was a time bias, like people who comment first are typically those comments often rise to the top. So there's a bias in terms of time. There's a bias in terms of length. Some models will will prefer longer comments to shorter comments. So is there a specific type of bias that you're thinking about that you wanted to address?
In your example, maybe it's not the way the bias that I thought about, but maybe in filtering tweets, what is considered as, because that was my task, considering is this tweet in Arabic, is this a racist tweet or not?
Civility, yes, yes. So that's a tough one. So civility is a classifier typically, not a ranking, right? So ranking is you know, assuming these are all fine comments, which ones should we surface to the top? Civility is which comments should we remove? And again, that's a difficult one, because you typically need human beings to label examples of racist comments so that your model will know which ones to remove and which ones you know, to not remove. And removal of comments is a very touchy subject, because you know, it's generally companies don't like to remove content unless they're sure it's bad. That's why you see Twitter often kind of not react quickly in some situations, because their models are not telling them that certain things are bad. And in some other cases, they remove comments too quickly because their models are kind of giving false positives. So I think in those types of situations, you know, the thing to keep in mind is to make sure your sampling methodology of comments is good, and that you have ultimately humans labeling them. So what I would encourage in those types of exercises is to, you know, take a sample of 100 or a couple hundred comments, go through and label which ones are obviously racist, for instance, and then train your model on that and have it you know, run a simulation and predict scores on a larger sample. So the problem is the bias always typically comes from humans. And the human bias is incorporated in the model. The model itself is just doing what humans are training it to do. So the bias ultimately comes from humans in either their labeling or in how they're you know, designing the model.
Okay. Thank you, Parsa. The guys are, most of them, like half of them have left. Do we have time for a last question, maybe?
Sure.
Okay. Any last question, guys? Okay. Okay. Thank you. So thank you very much, Parsa. We have Abdallah. Abdallah wants to speak again. Yalla, go ahead, Abdallah.
Sure.
Sorry, but for just using the last minute. So so basically, as a user, I have noticed that, and many other users have noticed that there is a great difference between the recommendation algorithm for multiple apps. So, for example, there is TikTok, there is YouTube, and let's say, for example, Apple. So the recommendation algorithm for YouTube is very, very, very good. And also for TikTok, it's something from, I think, outside this world. It's unbelievable.
It's
But
really good.
yeah, but for like recommendation through Apple apps, music app or other apps, it's extremely bad. So
Yeah.
I would like to ask you, is that the matter of concentration? So is the company concentrating on this matter or not, or is the matter of it's a secret of the industry? So some people know how to do it and some people don't.
It's often a matter of how long people have been working on it. You know, because as you work on a problem longer and longer, your solutions become better and better. Keep in mind, YouTube started what, in 2007? You know, so it's had about 15 years to work on content recommendation. And, you know, it started off with very simple type of like modeling, and now it uses a very complex neural net for its recommendation system. TikTok, if you remember, started as Musical.ly back in, I want to say 2010, or you know, in that era, and then later Musical.ly changed into TikTok, and so they've had about at least 10 years working on that too. Apple didn't enter the kind of like the video streaming business you know, until much more recently. And as a result, those types of infrastructures and the type of like investment in talent and belief that we should pay people a lot of money to come and work on these recommendation algorithms for us. Those typically take time. The other thing I'll mention is that TikTok and YouTube are what's called user-generated content. You and I can go create content and put it up there, right? So there's a lot more stuff to choose from. When you look at companies like Netflix or Hulu or Apple TV Plus, they have a much smaller library of content to show. And so then it becomes actually, in a sense, more challenging to show people the right shows because they don't have as much sort of input. They have a small content library, but each piece of content is a much deeper investment in time. So, you can watch a TikTok for 5 seconds and know if you like it or not. You can watch a YouTube video for 1 or 2 minutes and know if you like it or not. But, a TV show, for instance, is a much deeper commitment in terms of consumption. And so the user-generated content and the duration of the content will affect it. So you'll typically find that longer form content and that's not user-generated will typically have worse recommendations. That being said, Netflix has been doing this for a very long time, and so I would think Netflix's recommendations are typically better than most other streaming platforms that are not user-generated content.
Thank you very much, Parsa. Thank you, Abdullah. Thank you, Muhammad. Thank you, everyone, for attending. I'll stop recording now. Stay with me, Parsa, if you agree.
Sure.
Okay. So.